the other end, without further ado, introduce Ali. We have seen Ali here.
Yeah. All right. Thanks. Thank you, Pritika. All right. Hey, everybody. Thank you for coming today. I was a bit afraid that no one's going to show up, so great to have you here. So today I'm going to present this session. It's two parts. I'll explain a bit more about it. So mainly it's about a path to better performance, leveraging AWS services for DB indexing and archiving. This is a use case that we've done at Fergus. Yeah, I'll talk a bit about it. Before I start, this presentation this is the second time I presented. First time I presented it alongside my colleague Johnny Shao in the AWS Community Day in Wellington. So this is the second time, and it would be great to get your thoughts on it and questions. So hoping to have a bit of discussion at the end. A bit about myself. I'm the platform team lead at Fergus. Fergus is a company that delivers software for tradies. We help tradies manage their jobs, finances, and so on. I'm also an AWS community builder. This is a program from AWS for AWS enthusiasts, people who like to share their knowledge, write blog posts, do presentations. It's such a great program. It offers lots of networking and exposure opportunity and lots of learning opportunities. So have a look at this program and register yourself on the waiting list. And I highly encourage you to register and try to get into that program because it has lots of cool benefits, mostly learning. Outside of work, I write a bit of blog posts and I cycle when the weather is good. Cool. So a bit of an overview of the session. So as I mentioned earlier, it's going to be two parts. The first part is going to be about indexing. The second part is going to be about archiving. We will have questions after each section. So first, we will talk about the problem. So how to maintain performance as the data volume increases. So we talk about indexing and archiving. Then indexing should be simple, should it not? And then archiving, where to move this data, this old data. In each of these sections, I'm going to talk about the approach selection, how we selected the approach, and the challenges we encountered and the implementation. Okay, one more thing as well. Just so that you don't get bored. So we have one question after each section. The person, please raise your hand, and the first person who raises their hand and answers correctly will get a swag from the group organizers, which was offered by AWS originally. Yeah. Cool. So efficient database operations are the backbone of smooth and seamless user experience. And this is in all industries. So it does happen in e-commerce, healthcare, social media, and other domains. And at Fergus, we do care about customers. So this is one of our values. So we noticed that we're having a bit of a performance problem. So the dashboard, which we have within our application, was taking around 30 seconds to load for some customers. These customers were the oldest customers on the application, which means these are the customers who have the most data. So we started doing some analysis. And we started looking from the front end, looking at the pages, and how can we improve them. So before getting there, so this is not just a problem for this customer, right? It was showing for this customer, but this was also an indication that as we scale and as our system grows, it's gonna become a problem for everybody. So we started looking at the pages that can be improved, and we identified the APIs that are originating from these pages, and then we push that to the queries that are being executed and the targeted tables. we relied on RDS performance insights and Sentry. So Sentry identified, let us know which APIs are the ones that are having the problems, and RDS performance insight matched the queries that are originating from these APIs. So what we've done so far there is that we found that there are some queries that could be optimized, and then we optimized them and we've rewritten the queries. However, that was not enough. We wanted to do something, we needed to do something different. And here we started looking into indexing and archiving. So indexing and archiving, the techniques are like the gears and levers behind the scene, which enable the database to deliver data at lightning speed. So for indexing, it accelerates the data retrieval and optimizes the query performance, enabling swift access to specific information. Archiving simplifies data management, keeping active databases fast and efficient, while safeguarding important historical records. Yeah. So mainly we started looking into these, and now we'll talk about the first section, which is indexing. So indexing is mainly, if you haven't worked with indexing in the past, so it's mainly like a catalog. If you are going to a library and then you have, if you want to research all the book, one book in all of the library is going to take forever, right? You're scanning the library. So you have an index. So this is like a catalog at the front of the library. You find the book, you know in which shelf it is, and then you go and grab it. So we needed to do this. Okay, but we had a problem, right? How can we do indexing? I mean, all DB engines offer you to just go and run an index, create an index. It's that simple. However, when you have data that's becoming really huge, hundreds of millions of records, so there might be a problem there, right? What will happen if you just ran the database, ran the index on that table? So we started looking into options. So the first option is, we use MySQL as this database. So the first option we were looking at, hey, let's just execute index as I just mentioned. So MySQL allows online DDL. What that means is that it's not going to create any locking on the tables. And it's going to, you can continue to use the table and the system normally while doing that. So this is amazing, let's just do it. And then we looked a bit more and did some testing. This operation is going to consume lots of DB resources, and specifically IOPS and a bit of CPU. So assume you have a table with 500 million records, and you run an index on that table, you create an index on that table. So that might take 1 hour. That might take actually 2 or 3 hours as well. So as you are doing this, you are consuming the resources, and because you have limited resources provision, then this is going to consume them, which is going to cause load on the system, and other queries won't be executed as smoothly. Of course, we can always increase the resources, but that was not the path we want to take. Another thing is that we have a replica, and when we execute the index on the first database instance, it's going to be executed again on the second DB replica, and this is going to create a replica lag because the execution happens sequentially. The replication happens sequentially due to the lag. And finally, this operation cannot be paused or rolled back, and that was the item that actually stopped us from actually going forward, because if something went wrong, we would want to stop it and fix it, because we didn't really want to have any impact on the customer while we are applying the indices. So we started looking into some other tools, and here or other ways to apply the indices, and we found 2 tools that were popular. The first one is Percona PT Online Schema Change. The second one is GitHub Ghost. It's called Ghost. So what these tools mainly do is that they create a copy. So you have to index the table. What they do is they create an empty copy of that table, and then they add the index on that empty table. It's fast. And then what they do, they start copying the data over in batches. It's great. The tools have limitations, which they either don't allow foreign keys, or they have limitations around foreign keys. Even in the Ghost one, you can find some GitHub issues that argue that a system should not have foreign keys. A different discussion. So finally, we looked at it from a pragmatic perspective. We are not going to add indices to these large tables every day. So it's not a frequent operation for us. So it was quite, a big task for us to spend time to learn these tools, because they are tools and they have bugs, and we need to overcome the limitations and all of that. So we decided, let's have a look at another option. And here, we decided to go into a mixture where we apply the online MySQL default online indexing alongside with a manual operation that we do ourselves, which helps us minimize the amount of downtime that would happen, or amount of impact that might happen while applying the indices. To explain this, a bit about our system. So, yeah, can you see? Yeah, cool. So we have here, this is our application. It lives in EC2, and it interacts with RDS MySQL. So we have a primary database instance and two read replicas. So what we decided to do is to create a third replica. And then, without connecting any traffic to that third replica, we made it writable. It's an option inside of the parameter group in AWS. So we made it writable, and then we went into it and applied the indices into it. It doesn't have traffic, it doesn't impact anything. And then we shifted the traffic to it. So we stopped traffic to replica 2, and then shifted traffic to replica 3. And while replica 2 doesn't have any traffic, we created the indices on it. So this is amazing, because a part of the traffic here is going to the table that has indices, which gave us also an opportunity to test in real time on production any side effects that the indices might have done. So once we're done, we shifted the traffic to replica 2 and replica 3, and now we can delete replica 1. Okay. So in this case, we ended up with application pointing to a primary that does not have indices and two replicas that have indices. That's a problem, right? We cannot continue like that. So, oops, I pressed twice. So what we decided to do is to take 1 hour of downtime and do a maintenance window on a Sunday and say, okay, we promote replica, which has the indices to a primary, and then we create new replicas from it and connect to it. We were okay with this. So that was the solution that we wanted to do. And then AWS made the RDS Blue-Green deployment generally available. So we thought, okay, let's explore the RDS Blue-Green deployment. What's happening? So you can see here we have two set of instances. The blue one, which is the main one that has the traffic to it. And when you create a blue-green deployment, it creates a new environment, which is the green one. And this one doesn't have traffic to it. So what happens here is that you get replication from the primary to the primary green, and so on from the primary green to the replica green, and so on to the second replica, which is green. This is amazing. So what we've done here is we made these green environment writable, and we applied the indices to them. One thing to note here is that there is a replication here, right? So we cannot do any schema change on the primary key. Indexing is all right, but for example, you don't want to do any other altering of the table schema, for example, because this might break the replication. So we've done that, and we still need a downtime. So there is a downtime as per AWS documentation that says up to 2 minutes or around these words. So we decided to also spend that hour which we took originally and then to do it, but we've done it with blue-green deployment. This did take just about 2 minutes of downtime, and that was great. Definitely, whenever we can, we're going to use RDS blue-green deployment in the future. As I mentioned, or I already mentioned one limitation for it. Then the second limitation, there are a few other limitations, such as event scheduler parameter must be disabled on the green environment so that no events are fired. It does not support the following features, such as the RDS proxy, cascading read replicas, cross-region read replicas, AWS CloudFormation, or multi-AZDB cluster deployment. Another thing which I hope AWS would support in the future is cannot change encryption configuration. So if you have your Blue environment without the encryption and want to encrypt it, you cannot use blue-green deployment. You need to go to the older way of promoting a replica to primary. For upgrading engine version on the Blue environment, and also both environments, both DBs need to be in the same AWS account. Finally, you need to make sure that there are no replica in between Blue and green when you do the switch over. Otherwise, this is going to take more time to wait until the replica is finished and then it does the replication. It has some nice feature though, which is timeout. So if you put a timeout of 5 minutes and it doesn't happen or something goes wrong, what happens is that AWS reverts it back. What AWS does behind the scenes is that they changed the name of the instances. So they put primary to primary all, replica 1 to replica 1 all, replica 2 to replica 2 all, and then they put the primary green to the original names. All right. So this is the first bit. And this is the question that I have. And then I'll take your question on this if you have any. So is it okay to use RDS blue-green deployment to rename a DB column? For example, changing the column name on the green environment, and why? Yeah, why? Yeah, okay. Yeah, but here is his hand first. Yeah, cool. All right, yeah, of course you can, because it will break the replication. Yeah, so cool. When he gets back, you get the swag as well. So he's getting it from the car. All right, any questions? Yes.
So, question for that. Can you do that create a new column first, and then you create it separate?
To create a new column on the. Yes. So you can. Yeah. So to create a new column at the end of the table, and then you delete. You're saying you want to delete the older one. I don't know if the replication is going to be broken at that point. Maybe not. So worth trying. I don't have them on the top of my mind. They exist in. Yeah, but. Yeah, there are lots of them, such as indexing. Yeah, and but yeah, changing the schema not so much. But if you add a column, yes, if you rename a column, it's not going to. It's going to be a problem. Yeah. there is a yes, there might be a lag. So when you create it depends also on the size of the DB, of course, and the resources that you have, and whether you have enough IOPS, for example, in CPU to cater for the replication. But yes, there is going to be a replica lag. For example, when you create the new instances, it takes a bit of time to copy over all the data and replicate the data. Also, if you execute any operation on the primary instance that's quite heavy, it's going to cause a lag on the on the replicas, because what usually happens is that each operation that gets replicated, it gets replicated sequentially. So assume you have create 1 million record and in a single transaction, for example, and this took 1 hour or like 15 minutes, okay? And then afterwards, there are more insert operations on the first one. So to apply this first 15 minutes transaction on the replica, it's going to take 15 minutes, right? While it's replicating these data, these other operations are going to wait. And this is what's going to create a lag for the lag. Yes, you're talking about the initial replica here. These? So this one here, yes, of course. You have replica here, and you have your data, your application connected to it, and the customer won't see the data that got created, so they will not see a consistent data name. Yeah.
But then this thing is like those replicas. Can you go back to that? Because this thing is not new, so I'm just trying to. So basically, you have an app called
yeah.
That's like that. Then you have a so in any ways, when you make any change, whether it's a new level, whatever.
Yeah.
Anywhere you change the data column, you have to replicate the change.
Yes.
Of course. So this one is like it's the same, even if it's replicated or not replicated. You have to always do some actions. You know what I mean? So even if you change, forget about blue and green.
Yeah.
Yes, even in regular one you can't change.
You can change.
You can change, but you still have to go back and change your application and start thing.
Definitely, because
this goes on the other way as well. So if you have a replication, like a replica of,
so that's like exactly what yeah.
You can do everything. The only thing is how much you want to put the effort on it, because it's not something new. I'm trying to say it has been happening. So you can do it, but the only thing is like we want to put it in a transaction somewhere, you can hold it and then change it.
So yes, you are right.
But it is doable.
Okay, can I answer?
Yeah, sure.
Yeah. So you are right. This is something that's not new. This is new. It's a problem that's been there forever. However, like what I'm trying to convey here is that the blue-green deployment does so, because when you create this column on a new table, for example, or do this operation on a table, and then it is a huge table, right? And it's going to be replicated. You have this replica lag, which we talked about, right? So this is an operational way of using blue-green deployment to reduce the amount of impact on the customers, and that's what I'm trying to convey. It does not solve the problem.
Because what I'm trying to say, like this question existed even without replica or with replica.
Yes.
Because you always have to make a change.
Yeah.
In some way.
Yeah. Okay. Sorry, I don't get exactly what is your question, but yeah.
No, but I'm just trying to say,
yes,
this problem exists in even a single standalone database as well.
Yeah.
Not just even, well, this is a replica.
What's the problem in a single standalone? The creation of the column?
No, it's called rename of column.
Yeah, it's going to cause a problem.
Yeah, because it's always going to cause.
Yes.
Also, when it's replica or
yes, definitely. Yeah, you're right. You're right, because yeah, of course. But I mean, yeah, if it's a big table, of course, definitely. Yeah. Cool. Any other questions? Yes.
So I just want to understand the problem to solve is you try to create new index to the database.
Yes.
How often you do that?
Not often. Yeah. And that's why, for example, our team decided not to go with using a tool such as Percona. However, I kind of really like Percona as a tool because it does, if you do indexing and you have huge tables, then I think that's something nice to do. Yeah, just apply, let the tool run and handle the indexing for you. But for our case, we're not going to add indices like very often. It's a non-frequent operation. So we're running it once. And then even though we were running it once, we were trying to minimize the downtime. And then RDS Blue Green deployment did help with that.
So basically, your important goal is to make sure when you create a new index, you don't affect the performance of your cluster.
Yes, 100%. Yeah.
Trying to deploy your application using the CFN, and you want to add the blue green, so you need to do it manually?
Yeah, they say they don't support CloudFormation.
Okay, but what about Bloom?
I did not try, so we did create it manually. Yeah. It doesn't support CloudFormation, this one. You cannot create Blue Green deployment with CloudFormation. Not at the moment. Oh, I don't know. Yeah. Yeah. For this one, yeah. I'm not sure, like, since we've done it up to now, there's like some AWS CDK or something that enables us. Yeah.
So if you added the RDS blocks, you need to remove it before deploying the blue green.
That's what they said. Yeah, that's what the documentation says. Yeah. Yeah, but it does have these limitations, and it does have additional limitations. I just picked a few that I thought. Are you annoyed by the sun?
Oh, okay.
Yeah. We can turn. Yeah, both of you. And Igor, should we turn it? Yeah. Yeah. I don't know if this is going to help you. In winter, it's a better space, I think. Yeah. Any other questions before we move to archiving? It's only for RDS, only relational. Yes. It's not going to use them until later down. So you'll be still reading like basically eventually consistent data. Easy flag and start it's a bit different from So when you create a new DynamoDB index, what you're saying is that you must still the table is still available because when you call it, because it creates a new table behind the scene. Yes. If you call it the index that does not yet exist now, the result is pretty obvious. So DynamoDB, every index has a copy. It's a copy. Yeah. So you don't even worry about the performance of your own data. You can just really more money. Nothing to the only index, the whole data. Yeah, it's like an AWS. They don't charge you for also why they is So yeah, I have another question. Yes.
If you have a database, have you tried using Aurora instead?
We did not try Aurora, but I I don't know, like you would still have similar problems, I guess, like to apply it, apply the indices, or to do like DDL operations. I don't know. Serverless.
What's it called? Yeah, the one is compatible, but not SQL.
Yeah, Aurora. Yeah.
So they distribute it first.
I think Aurora doesn't. I don't know enough because I haven't used it much. But I think Aurora doesn't solve this problem in specific. It's more. It offers a different performance or better speed. Yes, but I don't know if you apply an index, for example, to a very large table. I don't think you will still have similar issues. But maybe like the replication works differently there. I don't know on top of my head, so that might be a smaller problem. Yeah. Yeah. Sorry, I'm not very familiar with that. Cool. Should we move on? All right. All right. Yeah, we already did that. So, archiving. So another part of this is that this big data that we have in these large tables, some of them are log tables, which we use as well on the front end sometimes. And we've done like some analysis of how the customers are using them, and the customers mainly look at the past few weeks or months, or like let's say that's past few months. So, but then when you're still querying these tables, it's going to be slow as well, especially if it doesn't have the indexing. So it's a combination of indexing and archiving mainly. So we decided to trim these tables down and move the old data that we have into some other space, so that we reduce the size of storage in these tables, and then the queries might become faster. Yeah, so how about we archive this old data? So we've done also the same approach of looking into what kind of options we have. The first option was, hey, let's move data into a new table in the DB. And then we consider two approaches here. We create a script manually, whatever, JavaScript, PHP, and then copy the data in batches to the new table. And then we delete this data from the main table. Or we use a tool such as Percona PT Archiver, which does the same, but yeah, it just takes off this. So definitely here, you would need to manage as well, like how the batches alongside your existing CPU and other resources. We thought like it might be a good idea to look into other options. So we looked into doing MySQL partitioning. So partitioning is creating subtables. For example, if you partition by date, then we would have multiple subtables, and which we could query then, and they would be smaller, they would be faster. And Percona as well offer this ability. So we also face the same challenge, which is, hey, we got, sorry. No, I do not. Yeah, that's cool. Yeah, so here, because like of the problem, the same problem which we had with foreign keys and foreign key constraints, partitioning wasn't a possibility for us. So we thought, hey, let's look into a solution that's offered also using AWS services. So we already know how the database is structured. So we thought, okay, let's plug DMS, data migration service, into one of our replicas. And then from that database service, we copy the data over to Aurora. And then what's good about this is that we can still query Aurora tables in the same manner. We don't have to change our queries and all of that. So we started looking into this. and we found that there is a problem. So when we copy the data over, we need to delete the data afterwards from the first table. But the MS, when working with Aurora, it copies the data over, and then so these are insert operations, and then when we delete the data from the source database, the MS also replicates the deletion. So we end up with the data deleted, which defeats the whole thing that we want to do. So we did a bit of research about this, and we found a small solution, which is we put S3 in between. So what happens here is that we go from DMS copies the data from replica, from our replica into S3, and then from S3 another DMS task that copies the data into Aurora. So how does this solve the initial problem I mentioned? Is that when DMS copies the data to S3, it creates a new record in Parquet file, for example, in S3 for each operation. So for example, when you have insert, it creates a new record, it makes it insert, it puts a field next to it called insert, for example, or I. And then when you have a deletion, it creates a new record in S3 and it puts another field next to it called D. And then what we could do here using the second DMS task is that we migrate only the records that have insert next to them. That was good. However, we thought it's too much for what we want. We didn't really need that. So we stopped at S3. So we moved the data into S3. However, in order to query this data, we ended up using Blue and Athena so that we query this table from S3. It does have some challenges. So it is difficult to modify and delete the data in S3 Parquet files, so you need to create a script to do that. But the most challenging challenge is when you change the data store, the source data store, which is the DB we're copying from, it means we would need to restart the DMS task. A restart would override the existing data, which we copied. And this is not an option for us because we copied the data, this is the archive, we cannot delete it. So restarting the DMS is going to delete it. And then, so what was the option is so why is it a challenge? Because first, we can overcome it by having a new target, right? But the new target means that we might have a duplicate set of data. Why is that? Because DMS did a full load first, and now it's doing CDC, which is like capturing the new data and copying it over. So assume data from 1 month back, it's been copied over, right? So if we create a new task, it's going to be copied over again, even if a new target. So we end up with 2 targets in S3, and that was annoying. It is annoying. We might need to change the data source often because if you want to upgrade RDS, you would need to restart to DB, which deletes the existing storage, right? So it's a new volume. We did not overcome this, but we can overcome it through Athena and Glue by filtering out the duplicates. And the storage isn't very expensive, so that's okay. And finally, my question and then your questions by raising hands as well. So for archiving purposes, can we use a DMS replication to Aurora directly? All right. Why?
As you say, it will when you copy data, one time it will delete, it will be deleted also.
Yeah.
So that's why you should do it. You need to add between SP.
All right. Thank you. Use your swag. There are some more stickers for you to pick up. Any questions about the archiving?
When you actually give this to your app, you maintain a making sure that if you have to refer it from any other,
No, it's already copied into S3. We do have backups, of course. Of course, we have like frequent backups that happen all the time, but I mean, I don't think we need to use it because you have also like some kind of like proper security around S3 so that the data that's over, you can add MFA for deletion, for example, and deter it from being deleted easily. No, through MySQL queries, yeah. Yeah, but it's was not something we could do because of the existing foreign key constraints.
Yes. Did you face any issues with the files or when you copy things to S3? Sometimes there is UTC issues and changing the date. No,
we didn't. No, we did check the data. It's good. Yeah, the MS is, we're not like modifying anything in the MS task, so it's quite simple where the MS is doing the copy of this table with all its fields. Yeah. Yeah. So we're not doing any transformation. Yeah.
So I'm not sure if the table how much is left.
So I don't remember on top of my mind, but we did check how many tables, maybe a few years. Yeah, time-wise, a few years that are left. If the goal of the question is how much impact did it do?
Small.
Yeah. So I think it did a bit of impact, but I think that so I have here just like a bit of, this is a summary, no need to do it right. And then here I wanted to show what we accomplished. So for example, we did improve the dashboard by 150%. So this kind of page went from 30 seconds to 3 seconds, another one from 6 seconds to 3 seconds, and so on. And we got like a bit of a really nice side effect as well, which is here. So this is our IOPS, and as you can see, before the indexing and archiving operations, our IOPS was going quite high. And after we've applied these operations, our indexes went less than half of what we used to have, and this is quite nice. We did relax our DB resources.
So I just want to understand the point of this. You fix both SG and S4.
Yeah.
That's why I index them.
Yes.
Do you consider as a because you're using RDS as OLTP database, your query always is not performing well?
Yeah.
Do you think about actually get your database right?
I know.
You don't need that's
we did discuss it, of course, but what we wanted to do is we did not want to do a rewrite of our system. Our system was quite operating quite nice. It was not impacting lots of customers. It was a small amount of customers. So this was like a bit of a solution that enabled us to finish things in a fast manner and relieve this customer manner. And we did gain lots of things. Yeah. So it was more of a business decision on where to go here. And assuming we did not, for example, have these gains, we will definitely start looking into some other solutions such as a different DB.
Okay, so you just put more join and that's what it's more and more
I mean, yeah, I mean, like I feel how that you're now arguing for let's leave relational, but I do like that, you know, it's cool.
I understand that you don't want to spend money, that doesn't make sense.
Yeah. I mean, definitely RDS is more expensive than other databases. Yes. One point something tera. 1 point something terabytes.
Did you face any issues with KMS? Because RDS has its own encryption, and once you upload it to S3, you have S3 or something like that.
No. So the encryption that S3 does by default is the, I think is the one on the REST addressed encryption. And then you could still query it through Athena, and yeah. So no, we did not face any issue around that.
Once you upload it from S3 to RDS.
We're not copying from S3 to RDS. So
I'm not sure.
yeah, but yeah, we did not do it. So like this diagram is to copy it to Aurora again, and we did not do it. So we stopped at S3, and now we query the data we needed from Athena. Yeah. I'm not very familiar with it. It was not me who implemented it. Yeah. Yeah. The default one, yeah. But I'm not sure, to be honest. I cannot answer. Yeah. Yeah. Sorry, I didn't get that question. Yeah. So at the moment we stopped showing these historical records on the app because the customers were not looking into them. However, it's an in progress project. We might later plug in Athena to query it from within our app, for example. But we did not need to do this often. Yeah. Yes. So here when we were thinking about it, so the purpose of Aurora is to copy the data over to Aurora because we could also plug our app directly to Aurora without changing any queries. Because the same queries that we were using to query first DB, we could use them directly to query Aurora. Repeat, please. Yes, they are. This is the application. It's connected here. So no, it's the same. Yeah. It's not, because we did not implement this one. But Aurora was an option so that we make it easier for the app to also query it if needed. System, you will have the endpoint. So here so we have a configuration within our system that points to the endpoint of each primary and replicas. So we could also program it within our application to also look into Aurora for these specific queries. Why is it so here so this is the old data, and we are trying to move away from the existing tables, and Aurora was one of the options we queried. Another option could have been also to have another MySQL, this table in another MySQL database. Yes. It sounds like Aurora is seeding these old databases, right? Like these databases yeah. The sunset? We're not looking to sunset them, but like Aurora. This Aurora wouldn't have all the data which we have. It was only supposed to have only the historical data which isn't accessed frequently. So only archive data? Yes. Yeah. Yeah. Yeah.
Is the direction of data just numbers? So for example, if we had to retrieve some of the historical data, right? Is it retrieve or like the combined versions as well?
With this last solution which we have here, we can retrieve it from Athena. At the moment, Athena isn't connected to the app. So not on the app. Yeah.
But it can be done.
It can be done. Yeah. No, I don't think there is a problem to query that data from S3. Yeah. Sorry.
It's a case of see if anybody needs.
Yeah. We can get the data at the moment through a request from the app if they need it. Yeah, definitely. I mean, we did before doing this change, we did go into looking whether our customers are using this data. Still, sometimes like some customer might need to look at this data. And don't forget, this is log data. So it's not something that's very critical for the business. So for example, if it's data that's critical for the customers, of course, we wouldn't put it like in a way that's not very accessible. So if it was already data that is infrequently accessed, yeah.
Archiving for recent, have we considered a snapshot?
Yeah. So just like to copy the snapshot over to S3. Yeah, I don't remember. We did consider it, but I don't remember what was the reason we didn't go with it.
This is fragmentation, right?
Yeah.
Snapshot.
Yeah, we already have snapshots that are frequently there, but also, like we don't want like to spin up the database every time, But also there is a solution which is RDS 2S3 snapshot, which puts it in Parquet format as well. We did consider it, but I don't really remember what was the problem, why we did not go with that solution. I think we have it documented somewhere. It was a new feature, yes. No, I don't think that was the reason. We did try it. Ping me later. I can figure out. I can find it out. No, I don't think it's this. I mean, so Athena's cost is based on how much data you scan. So if you scan too much, if you use it, then yeah, of course, other than the storage of S3, which is cheaper than other one. But snapshot, the solution that was mentioned, is going to also lead to the data arriving to S3, which is the same cost, I think. Yeah. Any other questions?
So what's the next challenge? Running from the container?
Oh, that's a great solution. That's a great thing to do. Yeah. We do have other services that run in containers. So this is like, if you want to think of it, it's the core application, but we do have other services that run in containers or in serverless. Yeah, so some of them, this is actually, I think, quite common to have this kind of thing. And if you'd like to break it, just start breaking one piece at a time. But yeah, I think that would be very nice. Cool. Thank you, everybody. Yeah, go ahead.
Does Blue conditionally take out item deletions for
everything? I think we could plug also Athena directly to the S3 bucket without having glue in between. Maybe AWS does create the glue like the glue task then, like behind the scenes. But yeah, I think we can also query. I don't know. I think we needed glue. Sorry, because to understand the table schema as well. Yeah. Yeah, very good. Yeah. That's right. Yeah. Yeah. Yeah.
Or is everything a log?
It's all logs. Yeah.
You consider actually applicable to S3 to only one database anymore?
Yes, that's the thing, but it requires development, right? I mean, it does require like changing on the actual business logic, yeah.
Because if you use actually can read the S3 already.
Yeah.
So why you need to move it again? You want the log, just log how you move that.
You're right. At the moment, our application does not read it. Not yet. Yeah. Yeah. But I mean, in that case, we would need to plug it with the Athena SDK and read the data if needed. Yeah, or find another way to query S3. Yeah. Directly without. No, without. Just write the S3.
You can remove the whole PMS code.
No, you stop writing to the DB. So these log tables instead, what Tao is suggesting is that instead of writing to these tables, directly write to S3.
Also doesn't need to give that.
Yeah. If you are querying it directly. It doesn't work for our use case. It doesn't work for our use case. Yeah.
Also, your use case is one way, right?
Yes, it is.
But it's literally separate documents, right?
Yeah. Yeah. But even if this app wanted to talk to S3, that's okay, I think.
It's very easy.
Yeah. Yeah. Okay.
Cool.
All right. Thank you, everybody. I hope.